So R1 is this, next is R2, another is R3. This box from here to here is your loop 1. See, this circuit is complete from here to here. This is one box. E1 is electric potential of this cell and E2 is electric potential of this cell, EMF. In this circuit, I2 current is flowing from here, I1 is coming from here. So total current in this will be how much? I1 plus I2. And here only I2 is going.
So why only I2 0?
Just pay attention and then check it. There are two EMF E1 and E2 and three resistors R1, R2 and R3. If the current flowing in R1 and R2 be respectively I1 and I2, this I1 is due to E1 and this I2 is due to E2. Are you following it?
Yes, sir.
Then applying Kirchhoff's first law at the junction A. Junction A is where you should check. A is here. This is junction A. So if we apply Kirchhoff's first law at junction 1, I1 is coming, I2 is coming. So how much we should go from here? I1 plus I2. Are you following it?
Yes, sir.
I1 is going here. That's why only I2 is going here. You asked this question, no? Why only I2 is going here?
Yes, sir.
So from here, see this I1 plus I2 is going till here. Again, total current, you will apply junction rule here. I1 will go this side and I2 will go this side.
Okay, sir.
Have you followed it?
Sir, yes, sir. Is there any possibility that E2 will go straight and E1 will go this side?
It depends on their EMF.
Okay, sir.
And one more point you have to understand, this is positive terminal and this is negative terminal. So the direction of current will always take from positive, no?
Yes, sir. From positive to negative.
Suppose you reverse this cell, make here negative and positive, then direction will change. So for loop I1, what will be there? Minus I1 R1 plus E1 minus E2 plus I2 R2. This will be 0. This is for first loop. We have written no, sum of delta V is equal to sum of I R1.
Yes.
Delta V means difference in the potential. So potential formula is IR. So you calculate potential across this, that you will get I1 R1. Potential across this I2 R2. So minus I1 R1 plus E1 minus E2 plus I2 R2. This will be 0. For second loop means this loop. What we will be writing? Minus I2 R2 plus only one cell is there in that circuit, that is E2 minus I1 plus I2 R. This will be 0. These are the statements of Kirchhoff law. Have you written this much?
Yes, sir.
Have we done the combination of resistances in series and parallel like this? R is equal
Yes,
to
sir.
R.
Yes, sir. Done.
Okay. So this topic is completed. Next. Next is combination of cells. I will take 1 minute by the time you revise it.
Okay, sir.
बताइए थोड़ा. अच्छा. अभी तक परेशान किया. अब जैसे ये पूरी प्रोसेस तो इतना जल्दी होगा नहीं ये कुछ. ये वो नेचुरल में जा रहा है, आप परेशान मत होइए. कोई दिक्कत है नहीं अभी, अभी कोई दिक्कत नहीं है, कुछ होने वाला नहीं। ये रूटीन वर्क है, अभी टैक्स फाइल नहीं हो पाया था पैंडेमिक कोविड की वजह से। ये रूटीन है, इसमें मतलब कोई एडिशनल वर्क नहीं है रिलेटेड टू डिवीजन, कुछ नहीं है, वो टाइम लगेगा आपकी करने में। वो चलेगा, पर से परेशान मत होइए। और क्या हो रहा है? हाँ, इधर चला जा रहा है टाइम पास, समझ अभी कुछ नहीं होगा, निश्चिंत रहिए और प्रेशर भी मत ब्रेन पे मत लीजिए, क्या होगा आपके लिए कुछ होने वाला नहीं, सारा इवेंट फेवरेबल है, सिर्फ आप उसको ऑब्जर्व करते रहिए, क्योंकि ये संसार की घटनाएं ये समय समय पर घटती रहती है, इसे पकड़ना नहीं चाहिए। एक जैसा सिर्फ जल्दी नहीं करिए, घबराना नहीं चाहिए, कुछ घबराना जैसे मतलब कुछ आपके पास कुछ ज्यादा इस तरह का रहता है इंसिडेंट जिससे दिक्कत होती है, परेशानी होती है, क्या करेंगे, ऐसा कुछ आगे का एकदम भूल जाइए। जो परेशानी वाले पीरियड में आप अच्छे से चले तो आगे कोई परेशानी नहीं है, परेशानी अभी थी आपको, जैसे जब फाइनेंशियल फ्रीडम हो जाएगी तब कहाँ से परेशानी आपकी आएगी, आपको तो पूरा पता होगा कि मेरी इनकम कितना है, मेरा एक्सपेंसेस कितना है, तब तो कोई प्रॉब्लम ही नहीं आती आपको। यहाँ आपको अपनी इनकम ही नहीं पता है कब कितनी है तो दिक्कत। वो मान लो पैसा भी नहीं देंगे तो भी बिल तो देंगे, जो बिल यूज होगा तो वो उससे बहुत परेशान हुई है, पूरा एक्सपेंसेस कहाँ से दिखा पाएंगे, पैसा देना ही पड़ेगा उनको। हाँ बताइए कि परेशान मत हुए, कुछ होने वाला नहीं। Have you revised? Shaji, have you gone somewhere? Am I audible to you?
No, sir, I'm here. Yes, sir.
Okay. So just now we are going to do combinations of cells. So
Okay.
do you have torch?
Sir,
Means do you use torch or not sometime? Like nowadays
no,
people,
sir. Flashlight I use sometimes.
in mobile they have flashlights, so they are not going for torch. So previously
So
we use,
why?
then I can explain you what what it is combination of cell. Previously people were
Okay,
using torch,
sir.
no, for seeing the in darkness. So in that
Yes, sir,
torch,
I know what a torch is.
2 3 cells are you put together.
Yes, sir, I know that big one.
uh, we can get another
Yes, sir.
example also, like remote control of the this television, you can check 2 cells are there.
Yes, sir.
So there what we do, we combine 2 cells together to increase the EMF. This is E0, this is also many cells are combined together. This is external load R and this is current I. So this is in series. In this combination, the negative pole of the first cell is connected to the positive pole of the second cell. In this combination, the negative pole of first cell is connected to the positive pole of the second cell. So that way we have done this combination. So total EMF, EMF is an abbreviation for electromotive force. So total electromotive force is E effective. This is equal to sum of EI. Means total of all the electric cell. This is NE. Total internal resistance. Total internal resistance. This is equal to. Do you know the meaning of internal resistance?
Yeah.
Like your cell is there, no? This is cell.
Yes,
There will be
sir.
two electrode, positive, negative. So inside this you will fill electrode. So they will also offer the resistance. So the resistance offered by electrolyte present in the cell, that is called internal resistance. We write with the symbol R for this, small r, which I have written here.
Okay, sir.
So this will be equal to sum of I, Ri. So this will be N into R. So you see this resistance NR and this capital R, they both are connected in series, no? Therefore, total resistance of the circuit. This is equal to small nr plus capital R. Any problem?
No, sir.
Next, if the current in the circuit VI then I is equal to N into E divided by N into R plus capital R. This is the formula. This is the current drawn. There will be some condition. First one, if NR is far less than R. What is the meaning of this? It means if internal resistance of the cell is less than the external. So what you'll do? Your equation E will become I is equal to N capital E divided by R approx. When the internal resistance is much smaller than the external resistance, cell must be connected in series to obtain a strong current. Do you have any kind of problem?
No, sir.
Second part, let us see.
Sir, what you have written after cell?
Wait. When the internal resistance is much smaller, then the resistance uh, full stop here.
So then the external resistance.
Put a full stop here, because from here you will get next step. Cell must be connected in series to obtain a strong current.
Yes, sir. Continue.
Next part is if nr is far greater than r, then I is equal to ne upon nr. So this is equal to capital E divided by r, approx. That is, if the internal resistance of the connected cell is much larger than the external resistance, then nearly the same current is obtained. By n cells as by a single cell. Have understood it?
Yes, sir.
Second part we have to do when they are connected in parallel.
Sir, what will happen if they both will be equal to each other?
In such a situation, what will happen? What is your formula you see? Your formula is this, no, I is equal to Ne divided by Nr plus capital R. What you want to do? You want to make R is equal to R. Substitute
Yes,
the
sir.
value. Ne divided by N capital R plus R. So it will become Ne divided by N plus 1 R. So your current will be very low.
Yes, sir.
Have you understood?
Yes.
Next, we should see in parallel. In this combination, the positive poles of the cells in this combination, the positive pole of all the cells are connected to one point.
Sir, are connected to one point or negative point?
No, one point only. And the negative poles to another point. You can see it like this. It will be arranged. This is a diagram you should draw it. This is external R. Diagram have you drawn?
Yes,
First,
sir, John.
this you see internal resistance of the cell will be in parallel. So you write 1 by R1 is equal to 1 by R plus 1 by R plus up to n terms. So how much will it will come n by R? Therefore R1 is equal to R by n. So this is total internal resistance. We should change the page.
Sir, total internal
Resistance.
resistance.
I've understood it. What is this? Like there are many cells, no? They have
Yes, sir.
internal resistance R, R, R. So such kind of suppose n cell you have. So n by R.
We have taken up to entrance.
Next, total resistance of the circuit. This is equal to R by N plus capital R. Therefore, current I in the circuit, this is equal to I is equal to E divided by R by N plus R. This is equal to NE divided by R plus NR. So your formula is I is equal to N capital E divided by R plus NR. Next is condition here also you can apply. If R is far less than capital R, that is if the internal resistance of the cell is much smaller than the external resistance. In that condition, what will happen? You write your formula I is equal to NE divided by NR. So NN cancel, you'll get E by R. That is the total current will be equal to the current given by a single cell. Have you understood it? Second is
Yes, sir.
if R is far greater than R. This means that is if the internal resistance of the cell is larger than the external resistance. Then how much I will be? I is equal to NE divided by R approx. The current will become N times. Have you followed?
Yes, sir.
I should change the page.
Yes, sir. Yes, sir, you can change.
Have you understood it? There is one numerical. You
Yes,
can
sir.
do it. It's very small. For driving a current, for driving a current of 3 ampere for 5 minutes in an electric circuit, - 1350 joule of work is to be done. Find the EMF of source in the circuit. Your problem is this. Let us solve it. For driving a current of 3 ampere for 5 minutes. So I is equal to 3 ampere, T is equal to 5 minutes. Convert into second. So it will become 5 into 60 seconds. This is equal to 300 seconds. So let us find Q. Q is equal to I into T. So at the place of I write 3 ampere and T is 300 seconds. So it will become 900 coulomb. Next part of this question. E is equal to E stand for EMF. This is equal to W divided by Q. Substitute the value of W. W is equal to 1350 joule and your Q is 900 coulomb. Hmm? You'll get 1.5 volt. Are you getting it?
Yes.
One more question we can do it. Have you completed?
Yes, sir.
Question number 2. A battery of 10 volt am I audible to you?
Yes, sir.
An internal resistance 3 ohm is connected to a resistor. The current in the circuit is the current in the circuit 0.5 ampere. What is the resistance of the resistor? So we have to find resistance of resistor. So and terminal voltage. So let us do it. I is equal to capital E divided by R plus R. At the place of, we have to find this capital R, make it subject. R is equal to E upon I minus R. So do it. At the place of E write 10 volt. I will be 0.5. R will be 3. So this will become 20 minus 3. That is 17 ohm. Next part you should see. We have to find out terminal voltage. V is equal to E minus IR. Substitute the value. E is 10 minus I is 0.5 into 3. So you are getting 10 minus 1.5. That is 8.5. Have you understood?
Yes, understood.
So that's all for today. For the tomorrow, again we'll do.
Okay, sir. Sir, what time?
Almost same time, between 2:30 to 3:30 or 3 to 4.
Okay, sir.
You have some work at this time?
No, sir.
Okay. Thank you.
Thank you, sir.